All right, so taking a look at our first example here where we're looking to find the lateral area and the surface area of this triangular prism here. So starting off, we're going to go after the lateral area first. Now the equation for that is the perimeter times the height. Now before we get into actually solving it that way, let's talk about what that means. So it's the perimeter of the base. And if you look, when we're talking about the lateral area here, we're talking about these three rectangles that connect the two bases. So this top one here, that one in the back there, and then this one on the bottom. Now by doing the perimeter times the height, it's basically saving us time from going, okay, base times height of this rectangle, plus base times height of this rectangle, plus base times height of this rectangle. Instead of having the three bases individually, by adding them up and using the perimeter as one item here, that handles all three of the bases, and then they're all going to get multiplied by their respective heights, which is just the distance between the two bases. So that's what that formula means, just to let you know. All right, so going after the perimeter, if you look here, we got a right triangle for the base. We have 5, we have 6, we don't have the hypotenuse. So we're going to have to use the Pythagorean theorem to find that. So we got 5 squared plus 6 squared equals c squared, because again, we're looking for the hypotenuse, so that's the term that's by itself. Square 5, we get 25. Square 6, we get 36. We're going to add them together and get 61. We have that equal to c squared. Now we're going to take the square root of both sides because we want c. We don't want c squared. So the square and the square root cancel. We get c equals. Now you could go down to a decimal if you wanted. I'm always a big fan of just waiting until the very end so that you're not, not compromising your answer by rounding too early. So that hypotenuse, we're going to say it's a square root of 61. Now back to the lateral area. Now we have everything we need. We have the perimeter, or we have a way to get the perimeter and multiply that by the height. So the perimeter, we have our hypotenuse we just found, square root of 61, plus 5, plus 6, the other two sides, and we get a perimeter of 18.81. Now, I didn't round this on my calculator. I kept the actual full decimal in. So if your answer is a little bit off from mine, that would be why. So we have the perimeter now, 18.81 times the height. Again, that's the distance between the two bases, so we're using 7. When we multiply those two together, we're going to get 131.67 centimeters squared. Now, when we're talking about area, remember that's centimeters squared. Area, square it, yeah. All right, looking at the surface area. Now, that's the lateral area that we just found, plus the area of the two bases. That's what that 2b means. Now, we're doing 2 times the area of the bases because, you guessed it, we have two bases here. We got to factor in that triangle and that triangle. We already have the rest of the outer shell of the figure. We just need those two bases. So to get the area of a base, the bases are triangles, so we're going to do 1/2 base times height. Now remember, base and a height have to be perpendicular to each other, and we had that from the beginning. We had the 6 and we had the 5. So 1/2 times 6 times 5 is going to give us 15 centimeters squared for the area of a base. So we plug back into that formula. We have the surface area equals the lateral area we just found, which is 131.67, plus 2 times the area of a base, so 2 times 15, that's going to give us 30. When we add those together, we get a surface area of 161.67 centimeters squared.